All right, here's our first video in 5.2. We're going to continue talking about factoring techniques, and in this section we're going to talk about what we call basic factoring. Do you remember there are 7 different steps to follow anytime we're factoring? Hopefully you can fill in these 7 steps, at least 1, 2, and 7, because we've covered those already. What's step number 1? Putting it in order, right? Step number 2, look for a GCF. If there are 4 terms in my problem, in the last section, remember we talked about grouping, the grouping technique of factoring? Now, if there's 2 terms, we're either going to factor it with a difference of squares or cubes. And if there are 3 terms, we're going to do what we call basic factoring or bottoms up. We're going to talk about basic factoring now. That happens when we have 3 terms. Now, we've seen problems like this before. If I gave you an x plus 3 times an x plus 4. We've distributed or FOILed, or maybe you even do a box method, right? Where we can distribute all the terms through to each binomial. X times x is x squared, x times 4 is 4x, 3 times x is 3x, and 3 times 4 is 12. We can combine our like terms and get one polynomial. So we can take 2 polynomials, multiply them, and get one bigger polynomial, right? An x squared plus 7x plus 12. So what if I asked you to actually take that polynomial and go backwards? Could you actually make it into a product of 2 smaller polynomials? Factor it? Now, it's in order, there's no GCF, and it doesn't have 4 terms, so I can't really group it like I did in the last section. What we have to do is we have to try to make it look like a FOIL problem, right? We've got to take this polynomial and we've got to make it into a product of 2 smaller polynomials, 2 polynomials multiplied together. Now, if I have an x squared, could I break that x squared up into an x here and an x here? Then when I FOILed it, x times x would give me that x squared that I need. Now here's the hard part. I also have to think about what numbers are going to go here. I need the 2 numbers that are going to multiply to give me 12. But when I add their like terms together, I get 7. So what numbers multiply to positive 12 that when I add them together, I get positive 7? And you might have to write out the different factors next to it if you need to. So the factors of 12 are 1 and 12, 2 and 6, 3 and 4. Which pair adds to give me 7? Well, I got 3 and 4, right? So my numbers inside would be a positive 3 and a positive 4. Now, if I were to FOIL it, x times x would give me x squared, x times 4 would give me 4x, 3 times x would give me 3x, and 3 times 4 would give me 12. And when I combine those middle terms, I get my 7x that I started with in the first place. So the factored version of the x squared plus 7x plus 12 would really be an x plus 3 times an x plus 4. All right, let's practice some more. It'll make more sense as we do more and more and more. Look at example number 1. It asks us to factor, so you should be following those same 7 steps. Number 1, is it in order? Number 2, is there a GCF? How many terms are after that? 2, 3, or 4? If there's 4 terms, remember we group it. If there's 3 terms, we're going to try to basic factor. So if you look at A, it's already in order, and it doesn't look like there's a GCF. I notice that there are 3 terms, so let's try to basic factor it. Let's try to find 2 polynomials that multiply to give us our original. So I'm going to start off with those parentheses. I'm going to take my x squared and I'm going to break it up into an x in each term, in each binomial. And now I've got to figure out numbers. I've got to figure out the numbers that are going to multiply to 6 but add to 5. And sometimes students get confused and they can't remember if you're supposed to multiply to the first one and add to the last one or what it is. And so I try to give them a little trick, little helpful hints that might help. I always do alphabetical order. Well, A's first in the alphabet, so the A should be first when we try to factor, meaning I need to add to the middle term always and multiply to the last term always. Hopefully that helps. So what numbers multiply to 6, positive 6, that add to 5? And if you need to, write down all the different factors of 6. I know 1 times 6 is 6. I know 2 times 3 is 6. I can even go into negatives. I can say negative 1 and negative 6 is 6, and negative 2 times negative 3 is 6. Well, which pair adds to positive 5? Well, it's the positive 3 and the positive 2. So my 2 numbers would be positive 2 and positive 3. And it doesn't matter which order you put them in. You could have said x plus 3, and x plus 2, as long as they're both still positive. No matter how you write it, if you FOIL it or distribute, you end up getting what you started with. So those are the factors of x squared plus 5x plus 6. Let's keep going. Look at B. It's in order. There's no GCF. There's 3 terms. So let's try to basic factor it. Let's put our parentheses. Let's break up this y squared into a y in each one. Let's figure out what numbers multiply to positive 12, but add to negative 8. Again, if you need to, write out all the numbers that you think multiply to 12. I've got 1 and 12. I've got negative 2 and 6. You could even do 3 and 4. Those all multiply to 12. But what we need to find is the pair that add to negative 8. If you look at 1 and 12, those are going to add to 13, aren't they? If I do a negative 1 and a negative 12, those are going to add to negative 13. So what pair is going to multiply to positive 12 but add to negative 8? It looks like negative 2 and negative 6, right? So negative 2 and negative 6 would be the numbers that go inside. Now, double check by FOILing and see if you get the same answer as we started with. Y times y is y squared. Y times negative 6 is negative 6y. Negative 2 times y is negative 2. And negative 2 times negative 6, 2 negatives make me a positive 12. If we combine like terms, do we get back where we started? Perfect. So that means our factors are correct. We have a y minus 2 and a y minus 6. Or you could have said a y minus 6 and a y minus 2. All right, let's keep practicing. Look at C. See if you can factor this one. It's in order. It doesn't look like there's a GCF. And I see 3 terms. So I know I'm going to basic factor. I'm going to take the x squared and break it up. And now I've got to figure out what numbers multiply to negative 20 that add to give me negative 8. I have to multiply to a negative. That means one has to be positive and one has to be negative, right? And then I have to add to a negative 8. That means the bigger number has to be negative when I add them together. List the numbers if you need to. You should end up with a negative 10 and a positive 2. Take 2 seconds to double check. Is negative 10 times positive 2 negative 20? And is negative 10 plus 2 negative 8? If that's true, then you got the correct factors. Again, you can write it like this, or you can write the positive 2 first and the negative 10 last, and you would still have the same answer, as long as the negative goes with the 10 and the positive goes with the 2. All right, let's keep practicing. Look at D. Okay, be careful. Did I get anybody? Remember, our very first step in factoring is to put it in order. So hopefully you saw that, and you put the t squared, then the positive 5t, then the negative 24. I looked for a GCF, but there isn't any. And I noticed that there were 3 terms, so I know this is a basic factor. So let's write our parentheses. Let's break up our t into each one. And then let's figure out what 2 numbers multiply to negative 24, but add to give me positive 5. I have to multiply to negative 24, but I have to add to get a positive 5. If I have to multiply to negative, then one has to be positive and one has to be negative. And if I have to add to a positive 5, then that means the bigger number has to be positive. Did you get positive 8 and negative 3? Those are the only 2 numbers that'll work. Those are the only 2 numbers that when you multiply them, you get negative 24, but when you add them together, you get positive 5. So your 2 factors should be a t plus 8 and a t minus 3. Or you could say a t minus 3 and a t plus 8, but the 8 has to be positive and the 3 has to be negative. All right, look at E with me. E is a little bit different because we have multiple variables in here, but we're going to treat it the same way. We're going to put it in order if we can help it. This one's kind of hard because, like I said, there's lots of different letters. So let's go ahead and keep it if we're not sure. Let's look for a GCF. Well, I can't take out A's from everybody because this one doesn't have it. I can't take out B's from everybody because the first term doesn't have it. So there is no GCF. But I do notice that there are 3 terms. So let's try to basic factor. Now, if it's helpful or if it's more confusing to see all these different letters, maybe cover some of them up. What if I took away the B's and I just gave you this problem? If you had the problem a squared plus 4a minus 21, could you do that without the B's? Could you think of numbers that multiplied to negative 21 but added to positive 4? Well, I can break up the a's. I can put an a in each one, just like we've done with the x's. I can figure out what numbers multiply to negative 21 and add to 4, 7, and negative 3. And then the only difference is there should be b's in the back because there's a b squared in the back. Just like there was an a squared in the front, we need to make sure that when we FOIL it, we get a b squared in the back. So I need to make sure that I have b's in my second term in each one. You should have an a plus 7b and an a minus 3b. If you're not sure, FOIL it out. So what's a times a? A squared. What's a times negative 3b? Well, a negative 3ab. What's 7b times a? 7ab. And then 7b times negative 3b should be a negative 21b squared. Those middle terms are like terms. They have the same exact variable with the same exact exponent. So I should be able to combine those and get an answer of an a squared plus 4ab minus 21b squared. Isn't that what we started with? Perfect. So I know that these are the correct factors of that polynomial. A little bit tricky if you have extra variables, so ignore them for a second if it helps, but don't forget about them. Make sure that you bring them back in the end. All right, try F for me. All right, is it in order? Is there a GCF? Is there a number you can take out of 1 and 6 and 7 besides a 1? All right, so it doesn't look like there's a GCF, and it looks like there's 3 terms. So let's try to factor it. I can break up the x and the x. And now I've got to figure out what numbers multiply to 7 that add to 6. Now be careful on this one. You have to multiply to a positive 7. So factors of 7 are 7 and 1, aren't they? But what's 7 plus 1? Wouldn't that give me an 8 in the middle? And I don't have an 8 in the middle, so it couldn't be 7 and 1. So what about 7 and negative 1? That adds to 6, but be careful. What does that multiply to? Doesn't that multiply to a negative 7, and that's not what I have? So we've got to find the right numbers. We need numbers that multiply to positive 7 and add to 6. Well, shoot, I can't find any, right? There are no numbers that multiply to positive 7 and add to 6. And you can't multiply to 6 and add to 7. That's not the way it works. You have to multiply to positive 7 and add to positive 6. And I don't know about you, but I can't find any numbers. What that means is that this polynomial is not factorable. We call that prime. Now, just because you can't find numbers doesn't mean that it's always prime, so be careful. Make sure that there are for sure no factors that you can factor it into. If there's not, then you can say that it's not factorable, or we use the word prime. Okay? All right. Practice some of that before we get a little more complicated in the next video with your basic factoring. So maybe try some of the problems in my math lab before continuing, and let me know if you guys have any questions, okay?